Hi, today we're looking at section 7.2, which is properties of graphs of quadratic functions. Now in 7.1, you're introduced to quadratic functions and what our graphs look like. In this section, we will go over some key properties and terminology with those graphs. So, some definitions. A vertex is the point at which a quadratic reaches its maximum or minimum value. So, if we have this parabola here, this here would be our vertex. Now, because it's opening upwards, it's going to have a minimum value because that's the lowest y value that it can get because we'll have no points lower than it. Now, we can also have parabolas open downwards, in which case our vertex would be up here, and it will be a maximum value because we don't have any y values above it. We also have what's known as an axis of symmetry, which is a line that separates a 2D figure into two identical parts. So if this is my parabola, my axis of symmetry will actually go straight through the vertex. And if I drew this parabola perfectly, if we folded over this dashed line, this should overlap perfectly with this. Now, finding a maximum or minimum, since quadratics are symmetric, if we know two x values that have equal y values, the maximum or min will be located between the in an equal distance from the two x values. We can find the x value of the max or min by taking the average of our x values. So for example, what horizontal distance does the maximum height of a ball occur given the following graph? So we're given this graph here. What we can see is this y value and this y value are the same. So therefore, the x value at which we have our maximum will be exactly halfway between these. So to get the x of that x value for our axis, which will also be the x value of our vertex, that's just going to be the average of our x value, so of 1.5 and 8. So to get our average, we add them together, divide by 2. So therefore, the x value that this occurs at is 4.75. Now, we don't have enough information yet to figure out the y value of this location because they didn't give us an equation. But we'll talk about how to get that y value next. So if we're given an equation, we can use the x value of our maximum minimum to find the y value. So essentially, we will take that x value we just calculate, substitute into our equation, and solve for y. So example, at a local water park, the spray from a fountain is modeled by the equation y is equal to negative 0.12 x squared plus 3x. We want to determine the height at the various distances, and they've given us these distances, and then we'll find our maximum height. So what we'll actually do is change these distances they gave us into a table of values. So this is our x value, this is our y is equal to negative 0.12 x squared plus 3x. So we'll put the values in, so y is equal to negative. So for this first one, we have a value of 0, so we've got negative 0.12 times 0 squared plus 3 times 0 gives us 0. Next, we have negative 0.12 times 5 squared plus 3 times 5. That gives us 12. Next, we have negative 0.12 times 10 squared plus 3 times 10. That gives us 18. Next, we have negative 0.12 times 10 squared plus 3 times 10. Oops, sorry about that. I just realized I just used the same values here. We had essentially, this one was 15, so we needed to put 15s in instead of 10. So we've got 15 squared plus 3 times 15. That gives us 18. Next, we've got negative 0.12 times 20 squared plus 3 times 20 gives us 12. Next, we've got negative 0.12 times 25 squared plus 3 times 25. And that gives us 0. So we actually have a few sets of matching y values. So we've got the 18s here, we've got the 12s here, we've got the 0s here. We can essentially use any of them to average to find the x of our vertex or our x of our axis. So for x where our maximum value occurs would be, let's just say use these two. So 10 plus 15 divided by 2. So if that would occur at 12.5. Now to find our maximum height, we have our equation y is equal to negative 0.12 x squared plus 3x. So we've got y is equal to negative 0.12 times 12.5 squared plus 3 times 12.5. And that gives us a maximum height of 18.75.